Hi everyone, Mary here, and we have been talking about ionically bonding compounds. And now it's time to talk about how do you correctly name those ionically bonded compounds. And we're going to begin with binary compounds. Now, bi means two, as in a bicycle contains two wheels, and bicentennial, centennial means 100, so a bicentennial is 200 years. So how do you properly name these? And it's pretty simple. It's the name of the metal or positive ion followed by the name of the non-metal ion with its ending changed to end in IDE. So to practice this, we're going to go back to the compounds that we created and we bonded in the last video, and we're going to name them. So if you've got your notes, flip back to that, and here goes. And I am going to go ahead and name these, and I'm going to let you practice some before we're done. So magnesium and oxygen, it's the name of the first, and then the second one, its ending is changed to IDE. So this is going to be magnesium oxide, and it's going to be experience and time working with the material that's going to help you know where to chop this element and where to add the IDE. If you said oxygenide, that's just going to sound odd. And so it's experience that will help you figure out exactly how to transform that last name. Let's do a couple more. Magnesium and bromine. Well, the first metal, you write the whole name. So magnesium, and then it's bromide. Potassium and oxygen, this is going to become potassium and oxide. And you've been around long enough, you've heard people mention chemical names that you've heard of oxides that should sound moderately familiar. Let's take a look at this. Beryllium, Be is beryllium. And then sulfur becomes sulfide. Sulfur becomes sulfide, not sulfuride, but sulfide. Chlorine and strontium, remember we had to flip that around to put the strontium in front because that is the positive ion. So this becomes strontium chloride, strontium chloride. Calcium and phosphorus, so calcium. Phosphorus becomes phosphide. And you might ask, why did I write this down below? Because I was worried about running out of room. That's why. Sulfur and tin. Tin is our metal. And remember, this is the one we had to come up with the lowest common denominator, SnS2. And the name gets a little more complicated. This is actually going to become tin 4 sulfide. And you might be going, where the heck's the 4 come from, Mary? Well, we'll talk about that in a video coming up next. So what I'm going to ask you to do right now is hit pause, take a moment, and try naming these. Just take you a minute, and then we're going to go through these. Remember, this is how you learn. You try something, see how well you do, and if you make an error, we fix it right away, and that's how you get good at everything from baking cakes to riding bicycles. And I'll be back with you in just a second. All right, let's give this a go. Remember, the metal had to come first, so this becomes lithium. Iodine turns into iodide. I know that sounds funny, doesn't it? Iodide, but that is what it is. The metal sodium had to come first, so this becomes sodium. Nitrogen turns into nitride. These are tricky until your ear gets used to how to change that ending. Magnesium, and phosphorus becomes phosphide. Hydrogen, and oxygen is oxide, and that is the fancy $2 chemical name for water. So if you want to be schmancy when you need a glass of water, you can say, ooh, I need some hydrogen oxide. And you can show off to your friends and kin. Now, before we go, one of the tasks you have to be able to do is to go from the name back to the formula. So let's see if you can do this. Sodium oxide. We're going to go through a few together, and then I'm going to ask you to try a couple on your own. Sodium oxide. The metal is given first. So this is obviously the metal sodium. And this is obviously oxide. This is obviously the element oxygen. But you have to be alert enough to say, oh, it's that crazy oxide, and that comes from oxygen. Then we go through the exact same bonding steps that we've gone through before. The most common ion of sodium is +1. The most common ion of oxygen, because it's in group 16, is -2. Here's the nice thing. If you already know the name, odds are the positive one is written first, so you don't have to worry as much, which I kind of like. Then you ask yourself the question, are they the same number or different? They are different. So you crisscross, this goes there, that goes there. Na, the 2 comes down. Remember, you never put charges down below. O and the 1 comes over, and do we ever write 1s as subscripts? Never, never, ever, ever. So Na2O is the correct formula for sodium oxide. All right, let's try this one. Barium bromide. Barium is Ba, and remember, you can stop and hit pause and try and run ahead of me at any point in time. I love that. Okay, so this is barium. Barium is group 2, so that's going to be +2. Bromine is a halogen, so that's going to be a -1. Are they the same? No, they're not. So you're going to crisscross. This goes there, that goes there. Ba, the 1 comes over. We never write 1s as subscripts. Br, the 2 comes over, and we never write charges down below. So barium bromide. Okay, you know what's coming. Try these on your own, and then we'll go through them. Go from the name back to the chemical formula. All right, here we go. Sodium. Sodium is +1. Phosphide. Okay, that's the element phosphorus. Phosphorus is group 16 on the periodic table, -3. They're not the same, so you crisscross. Na3 goes down here. P1 comes over. We never write 1s as subscripts. NaP. Calcium bromide. Calcium, group 2, so that's a +2. Bromine is a group 17. It's a halogen, -1. Are they the same? No, they're not, so we crisscross. Okay, I know. Don't sing, Mary. Calcium, you never put the 1 down below. Bromine, the 2 comes down. Calcium bromide. Lithium and iodide. Okay, lithium is +1. Iodide is iodine from group 17. -1, you have 1 of each, so lithium and iodine. Pretty spiffy, huh? Okay, I want to prove dope, and that will do for this time. Okay, next time when we come back, we're going to start talking about these guys. How do you handle the transition metals in the middle? We'll see you then. Bye-bye.